Hey, I'm Jessica Polk, and I'm going to talk about designing STEM curriculum. So this week I read the article Designing for STEM Integration by Lima K. Berglund. In this article, Berglund describes the process a team went through to create a truly integrated STEM curriculum that would apply to public high schools across the country. So to begin, the team created 6 design principles for their curriculum design process. It started with contextualizing student work, specifying course and unit learning goals, employing a standard of the engineering design process as a framework, engaging students in sensible forms of the engineering design process, ensuring that science and math concepts are necessary for student learning, and to attend to the constraints of high school and school district systems. I'm going to go into detail over the first 5 of these. So for contextualizing student work, the team really wanted to make sure that they used STEM design challenges and ensured that each lesson within an activity within the units targeted engineering design practices using science, math, and technology concepts as support. The team wanted each challenge to have multiple potential solutions, meaning there's no one right answer. It wanted each challenge to require students to use the engineering design practices in the context of different disciplines in order to present the interdisciplinarity of engineering and STEM. They wanted each challenge to be framed within the context of a problem in society, and they wanted each challenge to utilize specific concepts from science and math so that students can use and reinforce their conceptual knowledge in these disciplines. As far as course and unit learning goals go, at the time that this team was working on the curriculum, there were no national engineering standards. They kind of had to create their own guidelines that they wanted for the curriculum. And those included gathering information, creating functional prototypes and models, acquiring, understanding, and synthesizing data that is relevant to the topic or challenge, documentation, and applying relevant science and math concepts. Next, the team wanted to have standardized engineering practices throughout the curriculum. They began by looking at the STAR Legacy Cycle from Klein and Harris, 2007, and they adapted that and created the Engineer Your World engineering design process, which is located or you can see it in this figure. All lessons in the curriculum were to be contextualized within this engineering design process. And Berglund states that it was almost a one-to-one relationship between the unit lessons and the engineering design process. Engaging students in engineering practices required that the engineering practices should be used by students in meaningful ways. The team did not want the lessons to have students just going through the motions of the engineering design practice or process, that they wanted each activity or lesson to have relevant reasons to use the engineering design process. In this curriculum that they were creating, the students will engage in different steps of the engineering design process in order to complete a challenge before the steps were defined by the teacher. This went along with Schwartz and Bransford's findings that individuals learn from direct instruction best after engaging with the content themselves. And making sure that they were including necessary science and math concepts, the team only wanted concepts that were immediately applicable to the challenge to be presented to the students in the lesson. Concepts presented in the lesson should support the completion of the challenge, but will not be explained unless the understanding of these concepts is fundamental to the completion of the challenge. So basically, they did not want the students to have all of this conceptual knowledge thrown at them that was not going to be immediately useful for the challenge. So for engineering technology design practices in integrated STEM environments, this article was a great example of how to create a STEM curriculum, an integrated STEM curriculum that's framed around the engineering design process. I really liked that math and science concepts were taught as needed so that they were supporting the engineering design steps and also that the engineering design steps being used in the lessons were supporting the need for the math and science concepts. I think this curriculum differs from a lot of others because it uses a STEM design challenge, so it truly integrates all disciplines rather than just a problem-based challenge or an engineering design-based challenge. As far as teaching engineering and technology design at the K-12 level, I have experience in elementary grades, and in my experience, all of the disciplines are typically taught by one teacher, making the integration of different disciplines a smoother process than in older grades where teachers are having to collaborate and coordinate with one another so that the background knowledge needed for these different challenges is already learned in other classes. Ideally, I would like to use a STEM-based approach like the one described in this article because it is an integrated approach. I really like that students are learning the topics as they become necessary, and I really appreciate that the lessons are based on real-world solutions and problems so that the concepts learned within the lesson are more applicable to the students' lives and also helps reinforce the concepts that they are learning. And here is the reference for this article. Thank you.